All right, I want to plot several different examples here and look at the differences between them. This is example 102. Uh, the first equation we have is x equals cosine t and y equals cosine t. So if I put that into Desmos, like this, um, and let's see, we're going to make t go from 0 to 2 pi. We get this graph, which doesn't look very interesting. Let me zoom in on it. All right, so we get that. And if you notice, it's just part of the line y equals x. Well, that makes really good sense. If you look over here at this, x and y are equal to the same thing. So with this, if we remove the parameter, we get y equals x. And notice the same thing would happen for this one as well. So what's the difference in those two? Well, let's come over here and look at it on Desmos. So I'm going to make this bigger. So we've got cosine t, cosine t. If I change this over here to b, and I'll let b range from 0 to 2 pi, then notice up here, starting at the top, it goes from up there down to the origin, then down to -1, -1. And we can't really see what's going on here, but it goes back up to the top. Oh, didn't mean to do that. It's kind of hard to see that, so I want to look at this. This is another Desmos page that I have written, or not written, but I put all these formulas into. And basically what's going on here is it's plotting the function cosine t, cosine t, and this a down here is going from 0 to 2 pi. So if you look at what happens, we start up there at the top, and the point moves down to the bottom and then back up to the top again. And that makes good sense, because if you're looking at cosine t, cosine graph, when we go from 0 to 2 pi, the value of this starts at 1, it drops down to -1, and then back up to +1. And that's exactly what's going on here on this. It starts at 1, 1, and as we go across, it drops down to 0, bottoms out, and then it comes back up to 1. Now, if we look at sine instead of cosine, what's going to happen there? It's still going to be the same little line segment there, because if x is equal to sine t and y is equal to sine t, you've still got y equals x. And if we're only looking from 0 to 2 pi, we're only going to have, well, actually, that's not the important part for this. If it's sine t, sine is always between -1 and 1. So if we graph x equals sine t, y equals sine t, we're going to get the same thing. There's a circle. We'll come back to that in a minute. We get the same thing there. But because sine does this, we're going to start at the point 0, 0. We're going to move up to the point 1, 1, back to 0, 0, down to -1, -1, then back to the origin again. So if we start here, notice we start coming out of the origin, go up to 1, 1. We eventually get back down to there, like this. Now that's a little easier to see over here. If I change both of these to sine, we get that. And if we start with our a at 0, point goes up, down, then stops. Yeah, it goes from there, it goes up, back down, and then stop. It's when it gets back up there. All right, Now, what do you think would happen if we change this from a t to a 2t? Well, if we change both of those to 2t, then what's going to happen here is it's going to compress the sine so that instead of looking like that, it's going to look like this. Between 0 and 2 pi, it's going to make 2 trips around. So if I do that over here and I play this once, it's going to make 2 trips up and down the line and then stop. Now, if I change this 2 to some other number, like say 5, and I do this now, it's going to make 5 trips up and down, but it's still going to be the same graph. So the graph itself stays the same, but the motion, its speed and its motion change. And things get really fun down here on this last one where c and d are different. So if I've got sine of, say, 3t, down here cosine or sine of 5t, we get this interesting shape here. If I put in a 3 into 7, we get that. Notice an interesting thing happens here with 3 and 9. It goes back to this relatively simple looking thing. Well, if this is exactly the same thing we would get if we had sine 1 and 3 here. The difference is, with this, when t, or a in this case, goes from 0 to 2 pi, it starts in the middle, it goes from one end, it goes to one end, goes to the back, and then stops in the middle. If I change this to 3 and 9, it's going to do the same thing, but it's going to make 3 trips. It's going to start here, it's going to come down to here, go back, then it's going to repeat that 3 times, and it's going to do it in the same amount of time, so it's going to move really quickly. So anyway, that's what we get when we start looking at sine or cosine and change the periods there.